Welcome friends. In this video module, we will learn about tree data structure. Now let us see what is a tree. A tree is a finite set of one or more nodes such that there is a specially designated node called the root. The remaining nodes are partitioned into n greater or equal to 0 disjoint sets T1, T2 up to Tn, where each of these sets is a tree. We call T1, T2 up to Tn the subtrees of the root. Now let us see some tree terminologies. Node. Node stores a data element. It is the smallest unit of tree. Parent. A parent is a single node that directly precedes a node. All nodes have one parent except root. Child. One or more nodes that directly follow a node are called child or children. Ancestor. Any node which precedes a node, itself its parent or an ancestor of its parent. Descendant. Descendant is any node which follows a node. It can be itself, its child, or a descendant of its child. Leaf or external node. A leaf or external node is a node with no children. It is sometimes called terminal node. Internal node. It is a non-leaf node. Siblings. Siblings are the nodes which share same parent. Depth of a node. Depth of V is number of ancestors. Depth of root is 0. Depth of node is depth of parent plus 1. Height. Height of V is maximum path length of subtree. Height of leaf node is 0. Height of internal node is maximum height of children plus 1. Forest. Forests are a set of disjoint trees. Subtree. Subtree is a node and all its descendants. Ignoring the node's parent, this is itself a tree. Ordered tree. Tree with defined order of children. It enables ordered traversal. M-ary tree. If in a directed tree the out degree of every node is less than or equal to m, then the tree is called an M-ary tree. Complete M-ary tree. Out degree of every node is less than or equal to m or 0 and the number of nodes at level 1 is m raised to I minus 1, then the tree is called full or complete M-ary tree. Binary tree. For m equal to 2, the M-ary trees are called binary and complete binary trees. Consider this diagram. We have drawn a tree. Here there are 13 nodes. Now the children of A are B, C and D. Similarly, H, I and J are children of D. Now degree of a node. Degree of node A is 3 because it has 3 children. Similarly, degree of node B is 2 because it has 2 children. Leaf or terminal nodes. Here K, L, F, M, I and J are terminal nodes. Here K, L, F, G, M, I and J are terminal nodes and the remaining are non-terminal nodes. Here A is the parent of B, C and D. Similarly, H is the parent of M. Siblings. Siblings have same parent. Here B, C and D have same parent A, so B, C and D are siblings of each other. Ancestor. Here A is the ancestor of every other node. Similarly, B is the ancestor of E, F, K and L. Level of a node. As we move on from root to the leaf node, we have levels. As we can see in the diagram, A is at level 1, B, C and D are at level 2, E, F, G, H, I and J are at level 3, K, L and M are at level 4. Here the height of tree is 4. Now let us see how to represent trees. The list representation. The list representation of tree which we considered in our previous example is as shown on the screen. The root comes first, followed by a list of sub-trees. The logical representation of tree. The logical representation of a node of a tree is as shown. It has one data member and there are other links which represent the address of the children to the next level. Now the types of trees. Following are the types of trees: general tree, binary tree, threaded binary trees, binary search tree, AVL trees. Now this is a general tree. This is an example of binary expression tree for A star B plus C minus D divide E. This is an example of complete tree with depth 3. Now the application of trees. Trees are used for class hierarchy in languages like Java, C++ and C#. Trees are used in file systems. They are also used in solving arithmetic expressions like infix to postfix expression evaluation. They are also used in storing hierarchies in organizations. In the next tutorial, we will discuss about binary trees and its operations. Thank you.